In this video, our focus is on a horizontal circular motion. You will find this type of problem is actually relatively simple compared to vertical circular motion. That's because when it's horizontal, we typically only deal with a single force, often the tension from a rope or a rod. That provides the entire centripetal force we need. So here we have a ball moving in a circular motion in a horizontal plane, and it's being held by a string. Now, if the string were to break, or if I cut it at any moment, what happens? You can imagine that the ball will instantly fly away, right? Now, also think about this. If the ball starts moving faster, the string will need a stronger force, which is a greater tension to keep pulling it back into this circle. That makes sense, right? The faster the ball goes, the stronger the tension force on that string becomes. The problem tells us that the string can only handle a maximum tension of 25 Newton. So we need to find out the speed of the ball at that exact moment when that tension force reaches to its limit 25 Newton. Or in other words, the maximum speed that the ball can move before the string breaks. We know that the centripetal force, Fc, is simply the net force acting on the ball. In the horizontal direction, we are assuming the surface is frictionless. So there's only one force pulling the ball inward, and it is the tension of this string, Ft. Therefore, the net force, Fnet, is exactly equal to the tension force, Ft. Then we have Fc equals to Ft. Now let's quickly look at the vertical direction. Here we have the gravitational force, Fg, pulling the ball down, and also the normal force, Fn, pushing up or supporting the ball on the surface. Because the ball is not moving up or down, we know these two forces, Fg and Fn, cancel each other out. So they are balanced or equal to each other. That means we can completely ignore the forces in the vertical direction for this problem. Okay, now let's move back to the horizontal direction. We've established that the centripetal force Fc is equal to the tension force Ft. We know the formula for centripetal force is Fc equals to mv squared over r. Right, so we can write our core equation as mv squared over r equals to Ft. We need to find out the speed, right? So to isolate the speed, let's first multiply r on both sides. That clears the fraction on the left, leaving us with mv squared equals to Ft multiplied by r. Next, we divide both sides by the mass m. So we have v squared equals to Ft multiplied by r, then divided by m. Take the square root on both sides. So we have v equals to square root of Ft multiplied by r, then divided by m. Now we just need to plug in our values. So v equals to square root. Ft is 25 Newton, which is the maximum tension force of the string. And according to the diagram, r is 0.5 meter, and the mass m is 1.5 kilograms. When we calculate that, the speed v comes out to 2.9 meter per square second. So this speed is the maximum possible speed the ball can travel at. If the ball moves any faster, the tension required would be greater than 25 newtons, and the string would break.